Let's take a look at this example right here, which is a example of working a precipitation reaction problem. So we've got, consider a 1.5 gram mixture of magnesium nitrate and magnesium chloride. After dissolving this mixture in water, 0.500 molar silver nitrate is added dropwise until a precipitate formation is complete. The mass of the white precipitate formed is 0.641 grams. So we got two things that they want us to answer. The first thing is calculate the mass percent of magnesium chloride that's in the mixture. So for the first part, we've got this 1.5 grams, and it's a mixture of two things, magnesium nitrate and magnesium chloride. And they want us to figure out what percentage of those out of those two things, what percentage of that mixture, that 1.5 gram mixture, how much of it basically is magnesium chloride. And the way that we can do that is because they react it with this silver nitrate, they make a precipitate from that. And we can kind of work our way backwards to figure out how much magnesium chloride. So sometimes these problems can be a little tricky to think about, to figure out kind of what the problem is giving me. How can I work my way to this answer? So I'm just going to start kind of slowly. I'm going to draw out what are the things we know. So first of all, I know we have a 1.5 gram mixture. So I'm just going to kind of draw that out. Sometimes it helps me to think through the problem if I kind of just draw out what's happening. So I know I've got this mixture here, 1.5 grams, and in this mixture is magnesium nitrate. The first key to this problem is knowing, first of all, for magnesium nitrate and magnesium chloride, you need to know what the proper formulas would be for that. So for magnesium nitrate, you need to know that the formula for that is going to be MgNO3 2. And then we've also got magnesium chloride in there, so MgCl2. They say that that's our original mixture. We dissolve it in water, so when we dissolve this, that means that what we're going to have now are, these are going to be dissolved into their ions. So I'm going to have Mg2 plus, and I'm going to have NO3 minus. I'm also going to have Cl minus as ions in the solution, and I'm going to add to that silver nitrate, AgNO3, and they tell us that what I'm adding there is 0.5 molar. That's the concentration of this that I'm adding in there. They say that we make a precipitate then. So I add this AgNO3 to this, and when I mix this with what I've gotten here, I make a precipitate, which is going to kind of sink down to the bottom here. And they tell us that they don't tell us what the precipitate is. They just tell us that white precipitate that we make in that reaction ends up being, we make a total of 0.641 grams. So I'm going to make a note down here that the total of that precipitate then is 0.641 grams for the precipitate. Okay, we want to figure out then this guy right here is what we're interested in. We want to know what percentage of this is MgCl2. And the only thing I know is that when I add this, I make a precipitate that is 0.641 grams. Well, before we even do that, let's just think for a second. For mass percent, whenever I'm figuring out a percentage problem like this, so for the percent by mass, it's always going to be the grams of whatever I'm trying to figure out. So the grams of MgCl2 divided by the total grams. Well, I know the total grams. It's 1.5 grams. So I know the total out of that mixture. But what I need is how many grams of this did I have? So really, this 0.641 grams, I'm going to have to take that and use my stoichiometry, converting from grams to moles to moles to grams of this to this. So my next step is going to be asking myself, well, what is this precipitate then, this 0.641 grams? Well, if we think about, if we list out what are the ions that are in that solution. So when I dissolve the mixture and then when I add this, what ions do I even have in there? Well, I know I've got Mg2 plus that is going to be in there. I know that I've got nitrate, NO3, which I'm also getting from the silver nitrate. So I have NO3 minus. I've got Cl, or chloride ions, so Cl minus ions, and then I've got silver, so Ag plus. And that's it. Out of everything, I have different ratios of those ions, but those are the ions that I've got. And so then I ask myself, well, what combination am I going to get an insoluble substance, basically? So I know that the magnesium and the nitrate, that's not going to be the insoluble thing because that dissolves in the beginning, and same thing with this. So I know that the magnesium, basically with these two, is not going to be soluble or insoluble, and it won't be with this nitrate either. So the only thing that, using our solubility rules, is going to be this silver with this chloride right here. That's going to be what I make down here. So I know then, based on my solubility rules, that this 0.641 grams, that has to be silver chloride is what I made. So I reacted this, I made silver chloride, I made 0.641 grams of silver chloride. Now notice they said that we added that until that precipitate formation is complete. So the reaction was, they used up everything they could until the reaction was done, meaning all of those chloride ions were used up. So however many chloride ions that were in this original mixture, all of them were used up to make this 0.641 grams of silver chloride. So my next step, I need to convert this 0.641 grams of AgCl to grams of MgCl2, which we know that process pretty easily at this point. But before I do that, I need to write out the balanced equation, because if I don't have the balanced equation for the reaction between this and this to make this, I'm not going to be able to convert between those things if I don't have the balanced reaction. So I'm going to write out that we've got AgNO3 plus MgCl2 to make. So again, we're going to have the silver going with the chloride, and the magnesium is going with the nitrate here. So AgCl and MgNO3, which is going to be like this because magnesium's plus 2, NO3 is minus 1, so I'm going to need 2 of those nitrates. Now the reason why this is important is because now I need to balance this reaction. I've got 2 nitrates here, so I'm going to need a 2 here, and then a 2 here to balance out the silvers and the chlorides. So now I know that for silver nitrate, it reacts in a 2-to-1 ratio with MgCl2 to make that precipitate. So now I can start with the actual stoichiometry to figure that out. So I know that I made 0.641 grams of AgCl. That's what the reaction made. So I'm just going to work my way backwards to figure out, well, how many grams of this then did I have to make that many grams of AgCl? So the first step is going to get into moles of this. The molar mass of silver chloride is 143.4 grams per mole of AgCl. Okay, so that gets us into moles of AgCl. Now I can use my molar ratio that I've got right here, because I'm trying to eventually get to MgCl2, so that's going to be my next step. Well, for every 2 moles of AgCl, there are 1 mole of MgCl2 reacted. And then I can get from moles of MgCl2 into grams of MgCl2 using the molar mass of MgCl2, which is 95.3 grams per mole of MgCl2. And now I can do the math. So 0.641 divided by 143.4 divided by 2 times 95.3. And I get, when I crunch the numbers, 0.213 grams of magnesium chloride. So now I've figured out that's how many grams that I must have had of that MgCl2. If I made this many grams of AgCl, that's how many grams of MgCl2 I must have started with. And now I can figure out the mass percent, which is just going to be, I'll do it right here. So the percent mass is going to be that 0.213 grams divided by the total, which is 1.5 grams. And then we're going to multiply that by 100% to make it a percentage. And if we do that, it works out to be 14.2%. So that is the percent by mass of that 1.5 grams. So out of that 1.5 grams, 14.2% of it is MgCl2. So that answers the first part. That's the mass percent then of that. The second part, determine the minimum volume of silver nitrate that must have been added to ensure complete formation of the precipitate. So we were adding this in here until all of the chloride ions basically reacted to make this. Okay, and the question's asking, well, what volume did we use of this 0.5 molar solution to react all those chloride ions? So again, we're going to use some stoichiometry here. Well, I know that if we look, we made 0.213 grams of MgCl2. Well, actually, we don't even need that one. If we come back over here, we know we made 0.641 grams of AgCl, right? So I could actually start with this number right here and work my way to how many moles of AgNO3. And the reason why I want to do that, let's come back over here for a second, make a little more room. We got to remind ourselves of this equation. So if we remember this, volume times the molarity will give us how many moles. So that's an equation that we've used over and over again. Well, we're looking for volume here. So volume is going to be equal to how many moles divided by the molarity, or the concentration. And that's what I'm looking for, is the volume of this. Well, I know the molarity that I use is 0.5 molar. So now I need to figure out how many moles then of that did I use. And so that's where my stoichiometry comes in. So I'm going to start with that 0.641 grams of AgCl. And I want to convert from grams of this to how many moles of this did I have, basically. So my first step is going to be getting into moles, just like I did here, get into moles of AgCl first. So I'm going to do the same thing right here. AgCl 143.4 grams. And then I want to get to moles of silver nitrate. Well, if I look in my balanced reaction, there are 2 moles of AgNO3 for every 2 moles of AgCl. In other words, that's a 1-to-1 ratio. So however many moles I have of AgCl, I'm going to have the same number of moles of AgNO3, basically. So I'm just going to write 1 mole AgNO3 over 1 mole of AgCl. We really don't need to put that part, but we'll do it just so we can see how it's going to, all those will cancel out to give us units of moles of AgNO3. And let's see, so what we're really doing is 0.641 divided by 143.4. Got to type that in my calculator real quick. 0.641 divided by 143.4. And we get a kind of small number here, 4.47 times 10 to the negative 3. That's how many moles of the silver nitrate. And then we just want volume. So we're going to use this equation right here. So the volume, we want moles over molarity. The moles are right here. 4.47 times 10 to the negative 3rd divided by the molarity, which is 0.5. So divided by 0.5, and we get 8.94, I should say, times 10 to the negative 3rd. Remember when we do this, when we take moles divided by molarity, we're going to get that in units of liters. So for this, we could convert it to milliliters. So it would just be 8.94 milliliters. And so that would have been the volume, the minimum volume needed of that 0.5 molar silver nitrate. That's how many milliliters of this we would have needed to add it to get all of the chloride ions reacted to make that AgCl.